Today's talk is on bipolar junction transistor as a switch. So here it is a NPN transistor in a common emitter configuration where it is connected to supply PCC through resistance RC and the current is collector current is IC, and we are getting output voltage. Input voltage Vin, which is applied to that base emitter terminal through a resistance RB, and the current flowing is IB. So when this transistor will work in a cutoff region, in that case it works as a open switch. The resistance offered by the transistor will be very high, so it acts as a cutoff region. It acts as an open switch in a cutoff region. While when we operate our switch in a saturation region, it acts as a closed switch, meaning it offers a very low resistance. So now let's see its output characteristic, which is drawn between output voltage and output current for a given value of input current. Here output voltage is collector to emitter voltage and output current is collector current IC for a given value of input current, which is IB, and the different value of IB when IB is 0 and when IB is 30 microampere or 60 microampere, or when it is 90 microampere, or when it is 120 microampere. As we notice, even when the IP is 0, there is very small little current that is flowing inside the flowing through it, and this region is called, which is highlighted, cutoff region of operation of BJT. And the line towards the right is active region of operation of BJT, where it is used as an amplifier, and towards the right is the region for saturation region, where it is used as a switch when it is operating in a closed switch, where it is offering very low resistance. Now suppose we apply input voltage which is minus V1 and it goes to V2 for time duration T1 and T2. This is input voltage that we are applied from T1, and then for when input voltage is negative, that is minus V1 for time duration less than, let's say, T1, then this will make base emitter junction reverse bias. This means the current that it is reverse bias, the current IB is 0 and the current IC almost equal to beta. We know the current IC is beta time IB. Since IB is close to 0, or for ideal case let's say it's 0, then IC will also be 0, or it is rather very small. So this means the resistance in cutoff region of operation RC cutoff equal to voltage V collector to emitter upon current IC. Since IC is either 0 in ideal case or very small, so our cutoff will be very high, or ideal case it is infinity. So in this region the transistor acts as a open switch. It will not allow current to pass through it. Now for the saturation region of operation, even it operates in a saturation region, in this region the voltage Vc2 is very small. It is actually close to 0 or usually around 0.2 volt. So the current or collector current in saturation region will be VDD upon RC. So this is the collector current in a saturation when BJT is operating in saturation region. Now the resistance when it is operating in saturation region will be VCE upon IC. where VCE will be very small or close to 0, and at the same time IC is large, so it means the R will be very small, so it offer has a resistance which is very low, so it acts as a closed switch. Here it is written it should be VCE.